Welcome to the Phenomenological Alliance channel. In this video, we will highlight the importance of incorporating contemporary achievements in psychology and physiology into the research of natural phenomena.
The concept of inertia did not exist in ancient physics. In the geocentric model, where the Earth was stationary and the planets moved in celestial spheres, the development of the concept of inertia was not conceivable. It was believed that the planets traversed celestial spheres propelled by an invisible substance called ether. The modern concept of fields has its roots in the notion of ether, regarded as a part of space with special properties. Essentially, ancient cosmology posited the existence of a field of forces within a cosmic vacuum to explain planetary motion. In Aristotelian physics, the motion of objects without force was not possible. A cart in motion that is not pushed will eventually come to a stop. Mechanical force was considered a contact quantity, which must be constantly active to maintain motion. With the rejection of the geocentric model, physicists delved into understanding the question of motion without the presence of the contact force. Galileo Galilei played a pivotal role in the gradual development of the concept of inertia. In classical mechanics, inertia is defined as the tendency for objects in motion to stay in motion, and objects at rest to remain at rest unless acted upon by an external force. When we forcibly pull the cardboard from under a coin, the coin falls into the glass due to inertia, as it resists a change in its state of motion. Alongside the concept of inertia, the notion of mass began to develop as a property of an object that quantifies its inertia. Heavier bodies with greater mass are more inert.
In both classical and relativistic physics, inertia is defined as a property of an object, rather than something directly perceptible through sensory experience. According to this perspective, humans cannot directly perceive inertia through sensory perception. The phenomenological approach always begins with first-person experiences from everyday life. Applying this approach, let's ask ourselves how we psychologically experience inertia. Psychologically, inertia is the experience of sluggishness when initiating movement, whether mental or physical. When we need to begin work, we often hesitate and feel sluggish. Conversely, once engaged in a process, we may require time to disengage. For example, when we are deeply engrossed in our work, we may feel compelled to continue even after hours, even if the boss has left. The psychological experience of inertia indicates an imbalance, a deviation from equilibrium. The same experience of physical imbalance is perceived through the sense of balance. Our sensory perception allows us to discern whether we are accelerating, decelerating, or changing the direction of motion. The psychological experience of imbalance aligns with the physical perception of imbalance. Now, let's shift our focus to the phenomena of balance and imbalance in the external world. When we start to move a container filled with water containing a submerged plumb bob, the plumb bob tilts in the opposite direction of acceleration. Equilibrium is established after some time, once a constant speed is achieved. Conversely, when we start to move a container filled with water containing a submerged float, the float tilts in the direction of acceleration. Again, equilibrium is established over time once a constant speed is achieved. On the contrary, rotational motion consistently demonstrates imbalance. When stirring the water with the spoon, Oil drops and sugar grains distribute differently relative to the vortex. Oil drops tend to move towards the center, while sugar grains move towards the periphery. Similarly, a swing on a carousel tilts away from the center of rotation. However, if persons on the carousel were holding lanterns, they might observe that the flame, being in a state of buoyancy, leans towards the center of rotation. In a car, the helium-filled balloon also leans towards the center of rotation, contrasting with heavier objects that lean in the opposite direction. Psychological and physical phenomenological insight suggests that the problem related to inertia extends beyond mass or weight alone. Inertia and inertial forces arise from imbalances. The phenomenological perspective relates inertial questions to the context of the body in the surrounding medium. In rectilinear motion, denser bodies than the surrounding medium are displaced from the balance point opposite to the direction of acceleration. The rarer bodies are displaced from the balance point in the direction of acceleration. In a circular motion, such as when spinning a stone on a rope, the stone that is denser than the surrounding air will cause inertial forces trying to re-establish balance disturbed by curvilinear motion. We feel these forces through the presence of centrifugal force. Centrifugal force acts to return the body to uniform rectilinear motion in which there is no imbalance. Conversely, when a buoyant body is rotated, the centripetal force acts to establish balance. Through this approach, phenomena like, for example, granular convection become self-explanatory. In mainstream physics, it is considered counterintuitive that the largest and the heaviest particles rise to the top. The existence of centrifugal force, or the natural motion opposite to gravity, is considered to be counterintuitive. On the contrary, in a phenomenological approach that prioritizes observation over interpretation, occurrences such as granular convection cease to be enigmatic. Phenomenology refuses to accept that intuitive facts like the presence of centrifugal force are, in fact, counterintuitive. Gravity representing heaviness and levity representing lightness are regarded as two poles of the same phenomenon. Free fall due to weight and free thrust due to buoyancy stem from the presence of imbalance. Motion resulting from imbalance manifested through acceleration, deceleration, or changes in direction is influenced by numerous factors beyond simply mass as a fixed quantity. This leads to the conclusion that inertial forces occurring during imbalance could be mathematically modeled as departure from equilibrium. Much like Hooke's law of spring restoring force that is formulated as a dependence on the distance from equilibrium. The constant c incorporates mass. In the case of free fall, it has a positive value. In the case of buoyancy, it has a negative value. As will be shown later, other factors also affect the value of this constant.
Based on the mistranslations of Aristotle's writings, Western civilization held onto the belief for over 2,000 years that humans have only 5 senses. It wasn't until the 19th century that it became evident that maintaining this perspective was unsustainable. Apart from the sense of balance located in the inner ear, it was realized that a man could, even with closed eyes, touch the tip of his nose and discern the position of his limbs. This perception is mediated by the kinesthetic sense, or proprioception. Additionally, a man possesses the ability to perceive the metabolic state of the organism, including the status of the immune system, a function known as nociception. Presently, The number of human senses recognized varies between 8 and 20, depending on the literature referenced. Moreover, phenomenological insights into the content of thinking indicate that the content of the world manifests itself to us in a dualistic manner from external and internal perspectives. This duality is also evident in sensory perception. External perception relates to the state and objects of the external world, revealed through exteroceptive senses. For example, the sense of sight is an exteroceptive sense through which we can detect changes in the distance between external objects. Conversely, internal perception pertains to our internal states, perceived through interoceptive senses. For instance, the sense of balance is an interoceptive sense through which we detect whether we are in a state of acceleration. Through this sense, we perceive whether we are subjected to inertial or counter-inertial forces. The insights gained from modern physiology and psychology, when retroactively applied to the study of natural phenomena, have the potential to enhance our understanding of these phenomena. Consequently, this could prompt the revision or rejection of previous formulations in physics that were once regarded as indisputable laws of nature.